In section 8, we are going to start with something called point-slope form, and we're going to use that before we put things into slope-intercept form. So point-slope form is something you're going to want to write down. The formula is given right here, but that's a little bit hard to read, I think, so let's get it into a format that's a little bit easier, and let's go to the bottom of the page to do that. The point-slope form is always going to say that y minus the y coordinate, and I'm going to put this in a different color here, y minus the y coordinate, which we call y1, is equal to your slope, which we usually call m, times x minus your x coordinate, which we call x1 typically. Let's keep our colors consistent here. The two that I made in orange here, the two orange, these two are both coordinates. That means that they are a point somewhere on your graph. The m is a slope. So let's go ahead and see how this works when we plug everything into this equation. So let's go back to the top of our page. The very first example says through the point 5, negative 4, we have a slope of negative 1/5. We need to write an equation for that. So it's going to be y minus our y1 is equal to our slope times x minus the x1. So if we're writing that out now and plugging things into that, we have y minus the y coordinate, which is right here of our point, negative 4. Y minus negative 4. And that is equal to our slope, which is given here negative 1/5. So we write that out, negative 1/5 times x minus our x coordinate 5, and that is it. This right here is the equation in point-slope form. However, it asks us to get it into slope-intercept form, so we do need to get y alone. Here we have a double negative minus a negative, so I'm going to change that immediately to a plus. So we have y plus 4 over here on this side. On the other side, we want to be able to get rid of the parentheses as well. So this is a time where we do want to distribute. We want the parentheses to go away. So we do want to use the distributive property to take this negative 1/5 and multiply it by everything in the parentheses separately. So let's go ahead and do that. We're going to have negative 1/5 times x, which is simply going to be negative 1/5 x. We also have negative 1/5 times negative 5, this part right here. Negative 1/5 times negative 5. And when we do that, you can either type that in a calculator or think through this one here. Negative 1/5 times negative 5, and we could write that as negative 5 over 1. And on top, we're going to have negative times a negative is positive. 5 times 1 is 5. On bottom, we're going to have 5 times 1 is 5. And that's going to simply go down to 1. So if you don't mind writing that out, you are free to do that. If you would prefer to do anything with fractions in a calculator, that is an option for you. So you'll get plus 1 here, because it did become positive. We'll rewrite, copy down our y plus 4 from the previous step. And the last thing, we do want to get y alone, so we need to undo that 4 that's being added. We need to subtract 4 from both sides. So we're going to add a negative 4 on both sides. And that negative 4 and positive 4 are going to reduce down to 0, leaving us with y equals negative 1/5 x. And we can see here we have a positive 1 and a negative 4. If we combine our like terms, our constant numbers there, we're going to get a negative 3. So plus a negative 3 or minus 3. This right here is going to be the equation that we got here, except translated into slope-intercept form, one that we can very easily graph from our knowledge of how slope-intercept form will work. I want to jump to another example right next to this. We'll clear some space here. We again are going to start with our formula. Y minus y1 is equal to mx minus x1. And we plug in our points. Y minus the y-coordinate negative 2 is equal to our slope 1 times x minus our x-coordinate of negative 4. I immediately see the minus and negative in a couple places, and I'm going to change that to plus to make this a little bit easier to work with. On the right side, I want to get rid of those parentheses so it'll be closer to slope-intercept form. I have a 1 out front, and I could distribute this 1 to everything here. And 1 times x is simply 1x. 1 times 4 is simply 4, so I get 1x plus 4 down in my next step. Translating from what I have above here, I have a y plus 2 that I will carry down. Last step, my goal this whole time was to get y alone. So I need to undo that positive 2 that's being added by adding a negative 2. And when I do that, I have like terms over on the right side. So I cannot add this with the x because an x is a different type of term. I cannot add those with just constant numbers. But I can add my 4 and my negative 2 to get a positive 2. So I'm left with 1x plus 2. Over on the left, the negative 2 and positive 2 that we added together went away by going to 0. We're left with y equals 1x plus 2. And that is in slope-intercept form. We've got a couple more examples. I'll just kind of go through quickly so that you can watch how this process works. You may need to pause as I will go fast through these. We start out with our formula, y minus y1 equals m times x minus x1. We have y minus the y-coordinate negative 3. And we have no slope. That's an interesting problem. And we'll get back to that. X minus the x-coordinate negative 1 right there. Well, this is all great, except for the fact that we don't seem to have a slope. So we need to do something about that. We need to actually calculate the slope. So let's do that now. We remember that we have x1 and y1, which we used right here. But we also have an x2 and a y2 from another point. And what we can do is do our slope formula. M is equal to y2 minus y1 over x2 minus x1, our slope formula that we used earlier. y2 is negative 2 minus y1 is negative 3. So minus negative 3. On bottom we have x2, negative 5, minus x1, negative 1. Since I have minus and negative on both top and bottom, I will change those both to pluses. And when I clean this up here, I have a positive 3 and negative 2, leaving me with positive 1. The positive is bigger, so my answer will be positive up top. On bottom, a negative 5 and a positive 1. The negative is bigger, so I will end up with a negative 4, and that's going to be my slope, negative 1/4. So I'm going to jump back into the problem I was working on earlier now, since I was able to plug that slope in. I have a minus and negative on both of these parts for my equation that I put together. Change those both to plus signs as well. Make life a little easier. In order to get y alone, I will just need to get rid of that 3 somehow. But before I get to that, I want to clean up the right side. I want to get rid of the parentheses by distributing. So I'm going to take that and distribute it to both the x and the 1, leaving me with negative 1/4 x plus negative 1/4 times 1. Anything times 1 is itself, so negative 1/4. That's equal to y plus 3. Since I need to get y alone, I need to undo that 3 by adding a negative 3 to both sides. And that's going to leave me with y equals, so those reduce, negative 1/4 x, and either you can do this outright or you can use a calculator. When you get this answer, a lot of times you're going to get negative 3 1/4, either if you do it in your head or on a calculator. What would be even better than that in most cases would be to use the improper fraction form, which you can get on your calculator as well, negative 13/4. So that's what I'm going to write, is plus a negative 13/4. And then this last example here, we are given points again. This time I'm going to try to calculate my slope right away. My points are going to be named x1, y1, x2, y2. And my formula says take the y2 minus the y1 over the x2 minus the x1. No double negatives this time. On top I have a negative 6. On bottom I also have a negative 6. Interesting enough. And that's going to reduce to, since the same thing is divided by itself, just a clean old 1. So my slope of 1 is what I will use. Now I go to my point slope form. Y minus my y1 is equal to my slope, which is 1, times x minus my x1. And this one's going to turn out to be a little bit easier than some of the others, because when I go to clean up this one and distribute so I can get rid of my parentheses, I'm going to simply be left with 1x, and 1 times negative 4 is negative 4. I have just y minus 1 here. I need to get y alone, so I need to undo that negative 1 by adding 1 to both sides. And when I do that, I'm left with y is equal to 1x, but I have some terms I can clean up here. A negative 4 plus a 1 are like terms. I can reduce that down to negative 3. And that is going to be my final answer for that equation.